This is AQA A-Level Chemistry. We're looking at multiple choice past paper questions from the amount of substance topic, and we're on set of questions number 8. 5 multiple choice questions for you to pause, have a go at, and see how you do. So with that in mind, let's look at the first question. And with this, we are looking at saturated solution of magnesium hydroxide. We have got a mass of magnesium hydroxide and we've got a volume. We want to know what the concentration of Mg2 plus ions will be within the solution. Well, let's start with the information that we have. We've got a mass of magnesium hydroxide, so let's find out how many moles that is. I divide that by the MR, 24.3, 2 16s, 2 1s, and it comes to 58.3, giving me a number of moles 2 by 10 to the minus 5. I can now take that and work out the concentration. I know how many moles and I've been given the volume. I've converted that volume into decimeters cubed here. Now from there, that takes me to 2.01 by 10 to the minus 4. When you take a look at the equation, 1 mole of MgOH2 breaks down to make 1 Mg2 plus and 2 OH minus. But that means on a 1-to-1 ratio, the moles of magnesium hydroxide we've just calculated is equal to the moles of Mg2 plus after dissociation. So the correct answer is D. On to the next question for you to try. And again, quite a lot of information to take on board here, but we've got the minimum volume of 2.56 molar hydrochloric acid required to react with an excess of magnesium if we were to make 5.46 grams of magnesium chloride. So my start point is the magnesium chloride. I'm going to take my mass, my MR, and I'm going to work out how many moles there are. And with this, we can see that we've got 0.0573. Now we can take that 0.0573 moles and the mole ratio to see that my moles of HCl that were reacted would be double that. Hence 0.0573 times 2. And I'm dividing my N by my C to give me my volume of 0.0448 decimeters cubed. Now that means that the correct answer is B or D. Both of those are the correct number. However, the question specifically says incorrect standard form. And for that, this number should be between 1 and 10. So for that reason, the correct answer is B. Next question for you to try. And this is it's an ideal gas equation question. So I've taken all of the figures there, my pressure, my volume, my R and my temperature. And the next thing I'm going to do is convert them into the right units. So pressure must go into pascals, volume must go into meters cubed. Temperature is already in Kelvin. And with all of them, I can rearrange PV as nRT to find N. I put those figures in and I get a number of moles value of 0.00256 moles. Now, if that is how many moles of H2 that I've made, I can use mole ratios to see that I must have started with 0.00256 moles of X. And if I now know that about X, I can use that along with the molar quantity and the mass of X. I can do M over N, and that will give me an MR value of 39.8. We've then simply got to find which of these is the closest fit to a mass number of around 40, and that takes us to calcium. Okay, on to the next question for you to try. Slightly different question to what we see commonly. It's not a usual question, but it is valid and it's reasonable that this can be asked. The gold we're going to start with, we have got a number of moles, 392, and we find the MR off the periodic table, 197, meaning we've got 77,224 grams. We want density in kilograms per decimeter cubed, so let's convert that, 77.224 kilograms. I then need to work on my volume. So I've got my sizes of the bar, It's 10 by 10 by 40 centimetres. That's 4,000 centimetres cubed. We want kilograms per decimetre cubed, so let's divide that by 1,000, 4 decimetres cubed. Now, density is mass divided by volume. We've got those figures, 77.224 divided by 4. And that takes us to 19.306. Correct answer is B. On to the next question, and this is all about balancing equations, but quite a tricky one. So the important thing to see here is that my K2, CR2, CR2, lots of it is already balanced. It's quite limited what we can do. And so I am going to start by taking a look at the SO4s. I've got 3 SO4s here and I have 1 SO4 here. That's 4 of them in total. So I need 4 H2SO4s to balance it. Once I've done that, the whole of the left-hand side is balanced. So I can now work on balancing my H's. I've got 3 H2s, I've got 4 H2s, that's 8, 14 in total. That means I need 7 H2O on the right-hand side to balance it. My ratio is 4 to 7, and the correct answer is C. That takes us to the end of this video. Thank you for listening, and goodbye.